UTY EMU-250 is a high-speed electric multiple-unit EMU being developed for Uzbekistan Temir Yolları, Uzbekistan Railways. It represents a major step forward in the modernization of Uzbekistan's rail transport network. The idea is to combine high speed, comfort, and reliability in order to serve intercity routes and reduce travel times significantly. The UTY EMU-250 is an export of South Korean train-making expertise, Hyundai Rotem, adapted to the local conditions of Uzbekistan. Its introduction is planned for 2027. Historically, Uzbekistan's rail system has been a legacy of the Soviet period. Track gauges, station platform heights, operational practices, and rolling stock were developed under different standards than today's high-speed rail systems in many other countries. Over the decades since independence in 1991, Uzbekistan has pursued a variety of rail upgrades, electrification, new rolling stock, station modernization, track rehabilitation, and in some cases, introduction of faster services, for example, the Talgo 250 Afrosiyab trains. These steps reflect both economic growth and increasing demand for transportation efficiency. The UTY EMU-250 is part of this continuing strategy. The purpose of the UTY EMU-250 is multifaceted. First, it will provide high-speed rail service on key routes, most notably between Tashkent and Bukhara, once infrastructure permits. By doing so, travel times between major cities will be reduced, which improves connectivity, economic integration, and convenience for passengers. Second, it embodies technological transfer, Uzbekistan acquiring advanced EMU technology, maintenance capabilities, and operational expertise from a leading foreign manufacturer, Hyundai Rotem. Third, the purpose includes elevating standards of passenger comfort, improved seating, better amenities, smoother ride quality, and more safety features. Fourth, the UTY EMU-250 would help in modernizing station infrastructure platforms, signaling, electrification because the train's specifications require certain standards. Finally, it is also a symbol of national development. A high-speed train is often seen as prestige, and signals Uzbekistan's ability to invest in and deliver advanced transportation projects. Contractually, Hyundai Rotem won a bid order from Uzbekistan Railways (UTY) in mid-2024 to supply the UTY EMU-250. The agreement includes not only delivery of train sets but also maintenance support, light maintenance for 2 years and heavy maintenance for 9 months. 6 train sets, 42 vehicles, are planned for delivery. The first set is expected to enter service in April 2027, with the remaining sets following by September of that year. In summary, the UTY EMU-250 is not just a new train. It is part of Uzbekistan's broader ambition to modernize its railway system, provide faster and better service between its major cities, and integrate modern technologies and operational practices. The UTY EMU-250 is based on the South Korean KTX EM, also called EMU-260, model produced by Hyundai Rotem. However, for its use in Uzbekistan, several modifications have been made to adapt to local conditions. Below are its key technical specifications and design features. Train formation configuration. The UTY EMU-250 will consist of 7 cars per train set, as opposed to the 6 cars used in the base KTX EM configuration. Length. The 7-car configuration leads to a length of approximately 175 meters per train set. Passenger capacity. It will accommodate about 389 seated passengers. Maximum operational speed. The UTY EMU-250 is designed to run at up to 250 km per hour in service. The original KTX EM has a maximum service speed of 260 km per hour, but for Uzbekistan, 250 km per hour is the target. Width and gauge. The width is approximately 3,150 mm. The train will run on the track gauge of 1,520 mm, which is the broader Russian-Soviet gauge used in Uzbekistan, rather than the standard gauge 1,435 mm used in Korea. Interior design classes. The UTY EMU-250 will have seating classes including VIP, Business, and Standard. This layering is similar to KTX EM's Superior and Standard classes but adapted for Uzbekistan's market. Boarding platform compatibility. As typical station platform height in Uzbekistan is quite low, approximately 200 mm, the train will have internal steps to allow boarding from low platforms. Unlike UTY EMU, which has level boarding at high platforms, these internal steps are a needed modification for compatibility with existing station infrastructure. Other technical aspects, though less detailed publicly, presumably include use of modern electric traction, regenerative braking, modern safety systems, overhead electrical supply, likely 25 kV AC, a common standard, and components largely supplied or manufactured by Hyundai Rotem and its supply chain. Approximately 87% of parts are expected to be South Korean products. In terms of manufacturing and delivery, 6 train sets, 42 vehicles, are to be produced. The order includes maintenance provision, 2 years of light maintenance and 9 months heavy maintenance. The first train is planned for service in April 2027, others following by September 2027. Design features also include focus on passenger comfort, better ride quality, likely sound insulation, good seating arrangements, likely Wi-Fi, modern amenities, though detailed specifics are not yet fully published. The adaptation to local climate, track conditions, and maintenance capabilities will also form part of the design, given that Uzbekistan can have hot summers, cold winters, and perhaps large temperature swings. While the UTY EMU-250 is promising, its successful implementation depends on overcoming several challenges. Local adaptation is key, as is supporting infrastructure. Here are main issues and how they are being addressed, or will need to be addressed. 1. Track and infrastructure upgrades. High-speed service at 250 km/h requires track quality, curvature, alignment, and signaling to be adequate. Many tracks in Uzbekistan were built for lower speeds and may not have been maintained for such high-speed operations. Upgrades to track bed, rails, ballast, bridges, tunnels, etc., may be necessary. Station platforms may need to be modified for platform height, platform length, and passenger access. Overhead electrical systems, signaling systems, and safety mechanisms must be modernized to handle the capabilities of high-speed EMUs. 2. Platform height and boarding compatibility. As noted, Uzbekistan's typical station platform height is approximately 200 mm, which is low. To permit safe boarding and disembarking, the UTY EMU-250 includes internal steps. However, internal steps slow boarding and increase dwell time at stations, and may pose challenges for people with reduced mobility. In the long term, raising platform heights or ensuring uniform standards may be cost-effective. But such reconstruction is expensive and disruptive. 3. Maintenance and operations capacity. Introducing high-speed EMU technology includes having the skill sets for heavy and light maintenance, spare parts supply, diagnostic tools, etc. Uzbekistan will need to ensure that its railway workshops are equipped, staff are trained, supply chains are in place. The contract includes maintenance support from Hyundai Rotem for 2 years lightly and 9 months heavily, but after that, local capacity will need to take over. Also, having good preventive maintenance regimes is critical for safety and for the reliable operation of high-speed services. 4. Climate and environmental conditions. Uzbekistan has considerable climatic variation, high temperatures in summer, cold in winter, possibly sand, dust in some areas, wide temperature swings between day and night. The EMUs must be adapted for cooling and heating, for sealing against dust, for materials that can tolerate thermal expansion, etc. Also, environmental considerations such as wind, sandstorms, snow in some regions may impact performance and reliability. 5. Energy and electrification infrastructure. High-speed EMUs draw significant power. The overhead catenary systems, substations, and the electrical grid must be able to supply consistent voltage and current. Losses in transmission, voltage drop, or power quality issues may degrade performance. Also, ensuring reliability of power supply backup, redundancy, is important. Uzbekistan has electrified many lines, but ensuring that electrification is suited for high speed, and upgraded accordingly, is essential. 6. Cost, financing, and return on investment. High-speed rail or high-speed intercity EMUs are expensive in capital cost, rolling stock, infrastructure upgrades, signaling, stations, etc. Financing such projects requires careful planning, Cost-benefit analyses, ridership estimates, fare structures, operating costs versus revenue. Uzbekistan will need to ensure that ridership is high enough, fares are set to balance affordability and cost recovery, subsidies or government support where necessary, while ensuring quality and safety. 7. Safety, regulation, and standards compliance. Running at 250 km per hour is not just about moving fast. It requires rigorous safety systems, signaling, automatic train protection, emergency braking, crashworthiness. Regulatory bodies in Uzbekistan will need to enforce standards, carry out testing and commissioning, staff training for operations, emergency handling, etc. Standards may need to be updated, inspections made stricter, and maintenance audited. 8. Integration with existing services and scheduling. The new high-speed EMU will likely share tracks, at least parts of the routes, with slower freight and passenger services. Managing scheduling, track capacity, passing loops, overtaking, and ensuring the high-speed services are not delayed is a challenge. Also, coordination with station operations, ticketing, connections, etc., must ensure smooth passenger experience. 9. Local acceptance and culture. Passengers are accustomed to certain norms. Introducing high-speed services may require changes. Ticketing, boarding, expectations around schedule adherence. Also, ensuring affordability and accessibility is important to avoid service being perceived as elitist. Safety perception, reliability, comfort will influence public acceptance. To address these challenges, steps being taken include the modification of the train design, such as internal steps for low platforms, manufacturing in South Korea with high share of parts ready, contractual inclusion of maintenance support in early years, and targeting key routes first, e.g. Tashkent-Bukhara. The phased introduction, starting with first train in 2027, others soon after, allows gradual scaling and adjustment. The arrival of the UTY EMU-250 will likely have significant economic, social, and strategic impacts for Uzbekistan. It also sets future directions for rail transport in the country. Economic impacts. Reduced travel times between major cities, for example, Tashkent to Bukhara, will lower the cost of time lost in journeys. This can improve business productivity, encourage tourism, foster regional trade, and facilitate commuting when possible. Infrastructure investment required, track upgrades, station modifications, electrification, signaling will provide jobs, stimulate suppliers, and may lead to spillover effects in construction, engineering, and related sectors. Enhancement of competitiveness. Improved connectivity often leads to more economic activity in connected regions. Manufacturing, services, markets, allowing firms to access broader markets, attract investment, and reduce logistics costs. Operational cost savings in the longer run. If the EMU can operate reliably and with good energy efficiency, costs per passenger km may be lower than older rolling stock, especially if electricity, is sourced cleanly or efficiently, maintenance practices are optimized, and capacity utilization is high. Social impacts. Improved mobility for people, faster, more comfortable, safer trips between cities. This can help students, workers, families, and others to travel more often, potentially increasing access to jobs, services, education, and healthcare. Regional integration and social cohesion. Better rail links can help reduce isolation of remote or less developed regions, making them more accessible, encouraging migration or commuting, enhancing national unity, and distributing economic opportunity more evenly. Environmental benefits. Electric trains produce fewer emissions per passenger km compared to cars or diesel trains depending on electricity source. High-speed rail can help shift people from road or air transport to rail, reducing emissions, congestion, and pollution. Also, noise and air quality in areas near rail corridors may improve. Safety and comfort. Modern EMUs typically provide better safety features, smoother rides, better seating, amenities, and less vibration and noise. This improves passenger experience and may encourage more people to choose rail. Strategic and long-term prospects. Standard setting. UTY EMU-250 can set a standard for future high-speed or fast intercity rail in Uzbekistan. Once high-speed capable infrastructure is in place, further lines may be built or upgraded. This may include expanding to other city pairs, possibly international connections. Technology transfer and local industry development. As Uzbekistan's rail sector and its suppliers adapt to the requirements of modern EMU rolling stock and high-speed infrastructure, local capacities in manufacturing, maintenance, engineering, signaling may grow. This could reduce future costs, improve local maintenance independence, and possibly lead to local production or assembly of components. Better utilization of human resources, training new engineers, technicians, and operators in high-speed rail technologies helps build human capital. Over time, this can spill into other sectors: transport, infrastructure, manufacturing. Challenges and risk mitigation. The success of the UTY EMU-250 will influence public confidence in large transport projects. Delays, reliability issues, cost overruns, or service failures could dampen enthusiasm and political support. Conversely, successful operation could build momentum for further investments. Financial sustainability. To maintain and expand high-speed rail, Uzbekistan will need to ensure ongoing financing for maintenance, operation, and possibly subsidies. Sustainability depends on ridership, operational efficiency, fair policy, government support, and good governance. Decisions made now on fair pricing, service frequency, maintenance regimes will affect the lifetime cost and viability. Future prospects. By 2027, with the first UTY EMU-250 in operation, Uzbekistan will have a modern high-speed EMU in service. Looking further ahead, potential developments include expansion of high-speed capable lines. More routes may be upgraded to support 250 km per hour or more, or new dedicated lines built. Improved station facilities and platform standardization, possibly raising platform heights. To facilitate level boarding, improving accessibility. Incremental improvements in rolling stock. Newer models may incorporate even higher speeds, better energy efficiency, more comfort, improved materials, or better climate resilience. Integration with regional networks or cross-border services, especially with neighboring countries whose rail networks might be compatible or could be upgraded. Adoption of digital systems, for signaling e.g. advanced train control ticketing e-tickets, mobile apps passenger information systems, predictive maintenance, etc. Environmental sustainability, potential use of greener energy for electricity, solar, wind, etc. efforts to minimize environmental impact during construction and operation.